So parallelogram law of vector addition. Now this is a special case of triangle law. Let us say how. I have my first vector as OA, and now my second vector, it also starts from same point O here. My second vector is OB. Right? I'm going to call this P bar and this vector as Q bar, and angle between these two is theta degree or theta radian, anything that you want to say. Now here we want to find the resultant of P bar and Q bar. Now in my my triangle law, my first vector started, it ended somewhere. My second vector started from the point where my first vector had ended, and then so on. So what I had to do is connect the tail of my first vector with the head of my second vector and just draw the resultant vector. But now here the problem is the starting point for both the vectors is same. So let's see how to do it. Now I'm going to make a statement. I say that just complete the parallelogram and your resultant is going to be along the diagonal of this parallelogram. Let's see how. I'm completing this parallelogram. Let's say OA, that is the OACB. I'm going to draw this parallel to my P bar and this parallel to Q bar. Now the logic is a vector can be, as long as you are not changing the direction and magnitude of a vector, it will remain unchanged. So what I'm going to do is I'm going to shift this vector Q bar from here to this position. Correct? So my Q bar comes here, and what I get is something like this. So my P bar here and Q bar here. I hope it is clear. Now, if my P bar is here and Q bar is here, now I can apply triangle law of vector addition, isn't it? So what I have to do, I just have to connect this point O with this point C. Simple, isn't it? This is my resultant, that is OC bar. So let us start writing it here. My R bar is equal to P bar plus Q bar, which we got from triangle law. Alright, we got this, we got the resultant. We also got this angle alpha here. So as long as you are going to do graphic, it's fine. You know the magnitude of P, you know the magnitude of Q, you know the directions of both of them, you know the angle between them. If you do it graphically, if you make a two-scale drawing, it is quite easy finding the resultant, but everywhere you cannot do that. You must have some mathematical procedure for getting the magnitude of the resultant. So how do I do that? What I'm going to do here is, again, I'll use red here. I'm going to extend this here, and I'll simply draw a perpendicular from this point C here. Correct? What can we say about the whole thing now? Let us use some trigonometry. This angle is theta, angle between P bar and Q bar is theta. Now if I call this point D here, or I'm going to change it, I call this D. Angle between direction of P bar and this Q bar, it is going to be equal to theta. Correct? It is quite obvious. What can I say about this and this here? So if I consider triangle CDA, in my triangle CDA, my CDA is the right angle, my angle CAD is theta. So when I'm talking about cos theta here, cos theta would be equal to AD divided by AC. But my AC is equal to Q. So AD upon Q. Correct? I'm calling this number 1. What about triangle OCD? In triangle OCD, if I apply, now this angle alpha is the angle between the direction of initial my first vector and the resultant, and that angle I have written as alpha. In triangle OCD, my cos alpha is going to be equal to adjacent upon hypotenuse. So it is OD upon OC, that is equal to OD upon, I would say, R here. I'm just writing it here. Now, but then that doesn't give me magnitude of R, right? So for that I need to do something. What do I do here? I consider this triangle OCD, and if I apply Pythagoras theorem there, then OC square is equal to CD square plus OD square. What is my OD? My OD is OA plus AD. And whole square of that. So my CD square plus OA square, I'm going to expand this bracket, AD square plus 2OA AD, CD square plus OA square plus AD square plus 2OA AD. Now here, what you can see here is AD square plus CD square. Is it not AC square? AD square plus CD square and AD square. Is it not my AC square? So I'm going to write it as AC square there, plus, what is my OA square? OA square is OA square, plus 2OA AD, OA and AD. But then what is my AD? AD is my Q cos theta. So 2OA AD is Q cos theta. So this is Q square plus P square plus 2PQ cos theta. This is my R square. So my R is going to be P square plus Q square plus 2PQ cos theta, which is the resultant of my two vectors starting from the same point with angle theta between them. Correct? It is nothing but cosine rule. So we can say that when two vectors start from same point, the resultant is given by completing the parallelogram, and the final resultant, magnitude of resultant, is going to be the length of diagonal of this parallelogram. Now since we are talking about vectors, a vector has got magnitude as well as direction. Magnitude we have received here, we figured out. What about the direction? Now direction is, here you can see that the angle between the resultant and my first vector, it is alpha. Correct? So how do we quantify alpha? Now what I'll do here is I write tan alpha. Tan alpha is opposite upon adjacent, so that would be CD upon OD, and my OD is OA plus AD. For this AD, I know that AD is equal to Q cos theta. I want CD. So now over here tan theta, sin theta is equal to CD upon AC. So that is CD upon, it is Q, AC is Q. So my CD is equal to Q sin theta. So I am just going to substitute that there, Q sin theta upon P plus Q cos theta. This is my tan alpha. So I have magnitude here and I have direction here. So that is parallelogram law of vector addition. In the next video we are going to talk about resolution of vectors, and it is going to be quite useful thing in learning mechanics. Thank you so much.